Good morning, one and all. This is Dr. A.GOPI, Associate Professor, CSC Honors, and today we are discussing about that North-Morris pattern matching algorithm. Already we discussed in the pattern matching algorithms only. This is one more algorithm of North-Morris pattern matching algorithm, and this topic is available of a design analysis of algorithm subject. Now going to as the North-Morris pattern matching algorithm. So it's one of the algorithm checking left to right conversion of here to avoiding of a number of steps, to avoiding of a number of recursive steps. We can use that as a North-Morris pattern matching algorithm, and previously we discussed about that as a Navier-Stokes matching algorithm. Second one is that as a Robin-Karp algorithm, and now it is the third one, North-Morris pattern matching algorithm. So these properties we can use it as a algorithm is a complexity big O of n times, and previously we discussed about that as a O of n minus m times. Now it is the complexity of that as a reduction of some complexity we can go through on the North-Morris pattern matching algorithm. So same like as in the pattern matching here, text is a 1 to m and p is a 1 to m, text is a 1 to n, like that. Then only one comparison of KMP algorithm is prefix functions. So prefix function means, and prefix function means in the string we are able to go through on that string data, the prefix of the length of the longest proper prefix and substring of s of 0 of I, and which is also suffix of the substring. That means the given text should be having of some numerical values. That numerical values is able to representation of a 1 to many, 1 to 0, like that. So that is the case we can go through on that as a prefix the functions. Now in the definition of the prefix function, prefix of 0, the array of prefix is 0, then you can able to start initialization steps in the prefix 0 to k minus 1 times, and the shift is available of I minus k minus 1 up to I times of the prefix function. Then the components of a KMP algorithm. Then this is the pattern how to using of a prefix and suffix data. Now this is the example of here. The pattern is having of example. One is that ABC, DABC. This is the data we are using of the pattern format. Now in this prefix data, now we can go through on the prefix data. First letter is able to using of a one time single letter, and is there any data for the next letter to comparison AB, then this is the one more prefix, and ABC, this is the one more prefix of here, and ABCD, this is the 4 letters of the prefix data. And after that again A is the single, already it is came, AB is the another one 2 digit data, it is also came 3 digit data ABC. That means in the entire pattern of the data these are the prefix values, that is the starting to ending, the forward directions. Then now suffix data. What is the meaning of suffix data? The entire pattern reverse order of here backward to frontward. That means C, B, A, D, C, B, A format pattern. Now going to as a single letter C, here C first one, and 2 digit data BC, then 3 digit data ABC, then 4 digit data DABC. So these are the data is available of a suffix. Then after that C is a single data, BC is a double data, ABC is a triple data. So single, double, triple, and how many prefixes are there and how many suffixes are there. Then this is the normal way of pattern format. Then you can go through on the prefix algorithm and suffix algorithm in the forward direction or backward direction. It is able to using this pattern, it is a reduction number of comparison. That is the major role of here. KMP is reducing the number of comparisons using this prefix and suffix data. That is the major role of a KMP, and this part of the pattern is a using for the number of times to observations, how much to reach the data of a pattern. So going to next one is that as a KMP algorithm, this is the what we can say it as a pi table. So this is the pi table of a KMP. They have to create it on pi table. Through the pi table only able to comparison with the text. In the Robin-Karp we are having of a text format, pattern is a pattern format. Then we have created one mediator. Through the mediator only we are able to matching with that as a text only. That is a Robin-Karp. Now it is a KMP. They created as a pi table. This pi table is able to matching with the text only. It is only for forward direction. It is not a backward direction of the text. But pattern is forward and backward. Both will be done in the using this entire pi table only. Through the pi table only forward will be there, backward will be there in the pattern of the pi table. Now it is also called as the pi table is also called as the longest prefix, which is same as sum of the suffix. Then you can go for as a prefixes data and suffixes of the data using of the longest. Then in the shortcut we can say as a LPS array. So this KMP algorithm prepare the table of one table or anything. We can go through on the first one is that as a pi table. Without pi table, it doesn't want to comparison, because of this is the major role of a KMP algorithm. Now coming to that as examples. So first example here, pattern 1, A, B, C, D, A, B, E, A, B, F. Now the pattern of here A is equal to single, then that is equal to 0, B is a first letter 0, C is a first letter 0, D is also be first letter 0. All the zeros are available here. A is already previously it is available, now it is the 1, A is the 1. AB means already these are the two digit data is available of a previously, now it is a, in the B we can make it as a 2. Then E, it is a new fresh element is here, that is why it is a 0. Again A is there, already A is available of a 0, now we can make it as a 1. Then AB, this is a 2 digit data, then already it is available of a 2 digit data, now it is make it over that as a 2. Then F is a fresh data as a 0. So like that we can able to using the pattern of a 1. Then pattern of the 2, ABC, DE, AB, FA, BC. Now A is a single data 0, B is a single 0, C is a single 0, D is a single 0, E is also be single 0. Now A is having of a already previously it is available 0, now it is a 1, and B is also be available of a second time, but in the B we can able to matching with that as a 2 digit data AB. That's why B is a 2. Then F is a fresh data of here, that is a character is available 0. Then A is already available of a 0, but A is having the middle of the data of A is available 1. We don't want to go for as a is a 2, not like that. Always be matching with that as a first letter only. So A is a 0, now A is available of here 1. B is here again 2 digit data, then you can make it as a 2. Then ABC's data is available, already it is a previous data, ABC is there starting, then it is a 3 data. Now this is the way of representation pi table, second pattern. And coming to third pattern, A is a single 0, B is again A is also be there, 0 is already committed, then next one is the 1. Next B is 0, C is 0, A already 0 is available of A, already one time first time repeated, then we can make it as a is equal to 1. D is a fresh data is a 0, fresh letter. Then A is a 1, already 0 is available. AA means already 2 times the data is available of here, that's why second A is a 2. B already starting letter is A, B is available, now it is a 3, and it is a new letter, then you can make it as a 0. So this is the third pattern how to using of a pi table. Then fourth pattern, A is a 0, again second letter of the A it is a 1, then again letter of A is there 2, again the letter of here, why it is coming of a 2 means the data of here previously first one is the A, second letter is the 1, but these two letters are 2 digit, that's why here it is comparison of a 2 digit data, now it is a 2. Now again A is there, 3 digit of the data, then it is a 3. Then coming to B, it is a new letter is coming here 0, A is a 1, again starting of the A is a 0, now it is a 1. Second letter of A is a double A, that is already 2 digit of data is available 2. If may be available of A, it make it as a 3, but now we are having of a C is a new data 0, D is a new data 0. Like this we want to create of a pi table. This pi table is the key role of the KMP algorithm, matching with that as the main string. In the example of here KMP algorithm, we can able to go through on this is the string main string AB, AB, CA, BC, AB, AB, ABD, and the pattern is AB, ABD. This is the 5 letters of the data pattern. Now comparison with that as a pi table. Pi table normally we can go through on the pattern only, not for the string. Now AB, ABD, A is equal to 0 first time, B is also be 0 first time, A is repeated already 0, now it is the 1, AB, B is also be there 1, but here it is a 2 string data, that's why it is a 2. Now D is a new letter 0. So we are able to go through as a pi table of here, then only 0, 0, 1, 2, 0. This is the alphanumeric, this is the alphabets data. Now going to as the next data, the KMP algorithm is able to go for as that string AB, ABC, ABC, AB, ABD. Now this is the S index starting with the I letter, Now J index means pattern. It is a pattern alpha and it is a pattern numeric. Pattern numeric is 0 0 1 2 0. Pattern alphabets are A B A B D. So 1 2 3 4. These are the index of the pattern of the J, and 0 is the initialization. Starting letter is the 0. J means it is the initialization of the data. Now starting the KMP algorithm, how it will able to working. Compare the string of I is matching with that. Comparison string of the I is matched with that as a pattern of J plus 1. I is here A, then J plus 1. J plus 1 means this is the data. So A is matching with the A, is exactly matched. If both are matched, I and J plus 1 are matched, increment both J and I value. Increase the value of I, increase the value of J. J is here and I is next line. So that is also next line. We can take care about that. What are the values should be there in that. So now it is a string is in the B. I is index of a B. Now J index will be there at the 1. Previously it is 0. Now it is the 1. Now go to the second step to comparison. I is matching with that as a J plus 1 or not. I is matching with the J plus 1. B is matching with the J plus 1 B. Now B and B are both are matched. Matching is done. So if matching is done, increment both I and J values. Increment both I and J values. Now I want to make it as a increment the data I and J values. Now both I and J values are increased. Now comparing that here, I, A, J plus 1. J is a J plus 1 value A. So both are matched. Then I and J are increased. And the next step is able to go through that as a I and J values are both are increased. Now I, J values are increased. Now comparing with that as a I and J plus 1 value. I is equal to B, J plus 1 value is equal to B. Both are matched. I and J values are increased. Then we can move the next step of that as a I and J values are increased. Now here it is a comparison about that C, I value is equal to C, J plus 1 value is equal to D. This is the mismatch. Whenever mismatch is occurred, what is the next condition here? Else, if not matched, move the J to the index numbered by the P of J value. So if not matching is done, go to that as a J value. Here it is a J value. Now it is a J plus 1 value is mismatching. J indexing is here 2. So here it is a 2 means then the J value is moved to in this position of a second. That is J value here. See that as a the next step is able to move that where the position of data. Now the J value is equal to the second position. Now compare with that as I is equal to C and J plus 1 value. J plus 1 value is able to mismatching or matching. It is a mismatching the data. So mismatching data means this is the activation of here, and J indexing the data is should be there. That means J value is equal to here. It is a 0 is available. Now the J value is coming to this position. So whenever J value is coming to 0 position, I should be as a increasing, because of I values are always increasing only, there is no backward, but J values are increasing and same time sometimes it will come to reverse direction of the backward direction. So now the next step is that J is equal to 0. So now J is equal to 0 and I should be as a increasing the next step. So I is also be increased, and A compare with that, this is the case of here A, compare with the J plus 1 value, matching is found. Matching is found means I and J both are increased. I and J both are increased only. That's why next step is that I and J both are increased. Now B is equal to I is equal to B, J plus 1 value is equal to B. Both are matched. Both are matched means then the value of here I and J values are increased. So I and J values are increased in this position. Next step to I, J values are increased. Now the comparing with that C here and the J plus 1 value is equal to A. This is the mismatching. Whenever mismatching occurred and J position, the J position is equal to 0. Next line again come back to 0 only here in this of the J. Now the next position of the data is equal to, we can move to next slide 0. Then this is the final up to that is the viva verse. We can go through on the number of steps to comparison, and finding we have to given that as a I is D and 5 is J is also BD. Matching is found at the end of the string only. So there is only one thing to know about that. If j reaches the end of the pattern and I is reaches the n plus 1, then we can say that the given pattern is the present in the given string. Both are matching that here AB, ABD, then this AB, ABD is matching up to end line. The matching is found here in that as a pattern. Now, the basic idea of the KMP is the substring is able to pattern is able to moving the number of times. The pattern is here number of times to backward direction, number of times to forward direction. But here in the string is only for forward direction only. It doesn't want to go for as a backward direction. So this is the comparison of a I and j value. And same time complexity, m complexity and n, that is the m comparison of using n table. So table plus search is able to go through on that. So m plus 1 is the big O of m plus n is the time complexity of a string pattern matching algorithm. So string is able to go through on the normal text is a forward direction, that is the I indexing. J indexing is for that pattern of the here pattern alpha, pattern numeric. Then moving to directions of a j, it is a matching is done, both I and j are increased, mismatching is done, j indexing data is able to move the j value. So like that the string is comparison to first letter to ending the letter. If the matching is found with the pattern, then it is a found.